In today's video, here is a nice problem regarding arithmetic and number theory. It's coming from the Russian mathematical Olympiad. So here is the following setup. Find all primes p, q such that we have this following equation. We have p squared plus 3 times p q plus q squared equals a perfect square, which is x squared. Okay. Here is a nice and high trick. If you don't extract that trick, the situation will be more hard to solve this equation. Okay. So by the way, don't forget to hit the subscribe button and support the channel, like, comment, and subscribe. Now let's jump into the solution. So if you take a look at the prime numbers, for example, if you take the prime number p equals 5 or 7 or 11 and so on and so forth, and you square this prime and divide that prime by number 3, you see always you have a remainder number 1. Okay. For example, let's square 5 square. You get p square here, which is 25. If I'm going to reduce this one to mod 3, you get always 1 mod 3. Because 25 minus 1, 24 is always divided by 3. Okay. And you take 7 square, which is 49. Then you see the remainder 1 mod 3. Always. Let's take, for example, which is 11 square, which is 121. Always you get a remainder 1 mod 3. Because you get 120 is divided by 3. Okay. Take 13 square, which is 169. Always you get 1 mod 3. Okay. Except if you have p not equal to 3. Because this one works wherever the prime is except number 3. If you square number 3, you get 9. 9 is 0 mod 3. You see this difference. The only prime is have a problem as an odd prime, number 3. All others you get remainder number 1 mod 3. So based on this information that we have extracted from here, we are going to apply mod 3 on this one. I'm going to reduce this one to the mod 3. Okay, to see what's given us. Without loss of generality, we get p is inferior to q. Okay, but p not equals to 3 and q not equals to 3. Okay, so first of all, I'm going to assume p equals q. So we are going to see p, if p equals q, you will have a problem here. We get p squared plus 3p squared plus p squared, which is 5p squared, which equals a perfect square, which is impossible. Because we get the left hand side of this equation is not perfect square, but the right hand side of this equation is a perfect square, which is impossible. We are going to cancel this equality sign. We are going to leave strict inequality, okay, because this one doesn't work. So before we move on to the general case, we are going to check. Maybe we have p equals 2. Okay. If p equals 2, is going to give us q square here. Is going to give us 6q plus number 4. If I'm going to put this one on the form of the quaternary square, I get q plus 3 quaternary square minus 5, which equals x squared. This one is definitely not true because we get this one. Because you get this one is a perfect square, we move over 5 to the right, you get not perfect square, which is a wrong, okay, which is impossible. Okay? Which means p equals 2 is not valid. Now let's move on to the general case. So by using this factor we have here, if p not equal 3 and q not equal 3, so it's more simple here. We get p squared is congruent to 1 mod 3 based on the information that we have before with p not equal 3. Also with q squared is congruent to 1 mod 3. Also with q not is different than 3. Okay, I'm going to sum this one. I'm going to sum this primes. You get p squared plus q squared is congruent to 2 mod 3. Let's reduce the whole equation to the mod 3. It's going to give us p squared plus 3pq plus q squared is congruent to 2 mod 3. Because we get this one 0 because we have number 3 here. So which means this the whole thing equals a perfect square, which means x squared is a congruent to 2 mod 3, which is impossible. Why? Because when you have an integer and square it and divide it by number 3, you get the remainder 0 or 1, always, not 2, okay? Because you get x squared is a congruent to 0 or 1, which is a congruent to 2 mod 3. It's impossible, because if I'm going to use the quick chart here, so this one I'm going to reduce it to the mod 3. So we get the following reminders: 0, 4, which is 1, 0, 1, 0, 1. Okay, so this one is belongs to 0, 1 only. Okay, which is contradict our assumption, which means since p different than 3 and q different than 3 and give us this contradiction, which means at least one of these must be equals to 3. Which one is going to be number 3? Which is p, because this is the smallest one. Because you already tried p equals 2, didn't work, which means p is going to take number 3 in this case. Okay, now let's get rid of this one and move on to the second step. Previously we have proven p is going to take number 3, okay, which is strictly inferior than q. So I'll simply take this value of p and insert it back into the original equation to see what's given us. So I get the following: I get q squared plus 9q plus 9, which equals a perfect square. Here is a problem. Now we are going to face a big problem with the factorization. Okay, so how to factor this one on the form of the product? So here is a few tricks here to apply in order to factor out this one. First of all, I'm going to multiply the whole thing by number 4. Okay, so I get 4q squared plus 36q plus 36, which equals 4x squared. I'm going to take everything to one side. Okay, so get the following: get 4q squared plus, I'm going to split this one into 2 terms. I get 18q plus 18q plus 4xq minus 4xq. Okay, as adding 0 on both sides, as I did nothing here, minus this term minus 4x squared minus 18x plus 18x, which equals 0. Okay, let's rearrange this one. So we get 4q squared. Let's bring this 4xq next to this one, 4xq. Let's leave this 18q next to this one. Now we are going to finish with these 3 terms. Make sure we will have 9 terms here. Okay, don't forget this plus 36, because plus 36. Okay, then we are going to collect which has the minus sign here. So get minus 4xq minus 4x squared minus 18x plus the rest. The rest, I will have one of the 18q, because we have 2 of them here, 18q. Then if you take a look at this 36, this 36 is the same as 81 minus 45. Okay, I'm going to leave one of the 81 and move over this minus 45 to the right side. It becomes 45. Okay, we don't use the 18x yet, plus 18x plus 81, which equals 45. Okay, now we have done with these 3 things. We have collected each chunk with 3 terms, 3 terms, 3 terms, 3 terms. Okay, equals 45. I'm going to take 2q as a common factor for this one. I get 2q is multiplied by 2q plus 2x plus 9. If you distribute this one, it's going to give us this one exactly. Here I'm going to take minus 2x as a common factor. Minus 2x factor, I will be left with 2q plus 2x plus 9. Okay, for this one I'm going to take 9 as a common factor here. So I get 9 factor 2q plus 2x plus 9, which equals 45. We get 2q plus 2x plus 9 in each term. I'm going to take it as a common factor here. So I will have 2q plus 2x plus 9 is going to be multiplied by first term, which is 2q, minus 2x as a second term, plus number 9 as a last term, which equals 45. Now we have ended with a nice product here, which equals 45. I'm going to take this product at the top and continue solving this equation. Previously we were working on this one and came up with this nice product. Now we are simply going to solve this equation. So make sure here x is a natural number, okay? So always this term is going to take the small term, this one is going to take the big term, okay? So get 2q minus 2x plus 9 is going to take number 1. The big one is going to take the whole thing, which is 45, plus 2x plus 9, which equals 45. I'm going to take this case. You guys, I leave the other cases. You guys, you can do it. Okay, the other cases you will have no solution for that. So I'm going to solve this one. So what to do here? I'm going to get rid of 2x by summing these two equations together. So I get here 4q plus 18, which equals 46. Okay, for this term to the right, I get 4q, which equals 46 minus 18, which equals 28. Dividing both sides by number 4. So I get q equals 7. So we found the second prime, which is q equals 7. So we'll have a nice solution here. We get p equals 3 with q equals 7. But don't forget we have a symmetry here. So we get also p equals 7 with q equals 3. Okay, by symmetry reason. So all other cases, you will have this one equals 3. The other one is going to take 15. One of these is going to take number 5. The other one is going to take number 9. None of those works. The only solution that we're going to find, which is this one. Okay. So I have ended this video. By the way, don't forget to hit the subscribe button and support our channel. Thank you for watching. I will see you next video. Bye.